So, evaluating expressions, what does that even mean? What does this lesson mean? What does it do? Well, yesterday we went over this, right? For whatever. This is a good one. I didn't really go over the exponent ones yesterday, but this would be a good review. So this is order of operations right here. Solve the following problem. Okay, so we got to do what needs to be done first, right? Which is what?
Parentheses.
Parentheses. 2 plus 3 equals what?
5.
2 plus 3 equals 5. Make sure you make your life as miserable as possible and rewrite your steps step by step. So now we have to do what? If the P has been satisfied, which was the parentheses, and there's no more parentheses, or there technically is here, but obviously always ask yourself, is there anything to do inside the parentheses? In this case, there is not. So move on down your list. What we end up hitting is exponents. Is there an exponent? Yes. There is 5 cubed. What is 5 cubed? 125? I'll trust y'all. 4 times 125? Okay. So, what's the difference between evaluating expressions and order of operations? Well, literally, not that much difference, just this right here. Watch. So we're starting to incorporate letters, the famous letter, in with math. Now, next week we're going to really get into letters with math and really challenge ourselves with that. But this is just a very quick, this is the first stages of algebra that it's not that challenging. Because on the side, they will give us this. So, this, my friends, the type of question that might be given with this type of problem is evaluate the following expression when x equals 2 and y equals 3. My friends, there is no difference here. You just literally get the variable's value. By the way, variable. Variable is just a fancy word of saying the letter. It's the unknown number. So what is a variable? Unknown number, it's the letter, whichever of the two. You might want to write that down. Wink, wink, hint, hint. Memorize that. What is a variable? It is the letter. It is the unknown number. It is something that they're substituting the unknown number for with a letter. So you substitute the variable in the expression. By the way, this is the expression, aka the problem. You substitute all variables in the expression with its value that they have provided us. They have told us x equals 2 and y equals 3. So, here's the thing. Sure, in this specific problem, you could just put it into its designated spot. You could just put it into its designated spot the way it is. And you'd still get the correct answer. But there is a rule that everyone should keep track of. The rule. Do y'all love rules at this point? The rule here, when it comes down to evaluating expression, is whenever you substitute a variable with a number, you must first put parentheses. Okay, so the rule, whenever you substitute a variable with a number, you must first put parentheses around the variable's location. This is what I mean. This is what I mean. We already know what this would become. It'll become 500, whatever. Here's the thing. What if we're given this? 2x. X equals 3. Okay. If you, in this specific problem, were just to get the 3 and put it in for its x, you would get 23. Well, that's obviously incorrect. Well, not obviously. For some of you, this is all a new concept. The thing is, that is incorrect. You can't just put in the number in for the variable. You have to always follow the rule. And that's why even if there are certain problems, just like the one we did before, in which you might get the correct answer if you did just get the numbers and put it in for the variable, try to lose that habit. Try to make it a habit to always substitute first like this. Rewrite your expression, but in place of all variables, put parentheses first. And then put in your number. X, its value is 3. That's what they told us. That's what they give us. Yes, they will always give you when it comes down to evaluating expressions, they will always give you what the variable's value is. So on the side somewhere, or in the short paragraph that's on top, because this is a word problem potentially, somewhere in there they'll tell you what x is, or they'll tell you what y is. So you just get that value and you put it in. This is a lot different from 23. This means 2 times 3. What's 2 times 3? So 6 is the answer. So if we go back to the previous problem, again, if you did this, you would have been correct, because in this type of problem, you don't really need parentheses. But make it a habit. Oopsies. Make it a habit to do this. As tedious as this sounds, make it a habit to do this. What was that? Yeah, so watch this. It's just a good habit to have. You would still get the correct answer, trust me, even if you did it the other way. But this is a good habit to have for certain problems that you are all going to come across today. And sure, it takes a little extra step of rewriting your problem and then getting your values and putting it into its designated spot. Sure, it's just an extra step, but that extra step is going to help you, especially with what we're doing today. You see, this is a pretty straightforward evaluating expression problem. This right here is an even more simple evaluating expression problem, which all of you can do by hand because it's similar to order of operations, which we did yesterday. The thing is, today you are going to be testing out, we're finally getting into the groove of mastering our beautiful calculator. All right? So what does that mean? That means we're going to be given longer expressions, such as this. How about we do this one right here? (3x plus 6 over 2 plus the square root of 225. Actually, when x equals 4. Well, this is actually a pretty straightforward one too. This is actually a pretty straightforward one too. But we're just getting through the beginnings of the examples. So, what must we do first, my friends? Parentheses are in any of the variables that you could see. In this case, we just have one. So just make it a habit. Do this first. Just rewrite your whole problem. It's a good, extremely good habit to have. So now you have this empty parentheses where the x was. Tell me, what is x?
4.
So you put in 4. Okay, now you can solve this by hand, just like we did yesterday, and you'll be good. But the thing is, practice copying and pasting. What I mean by that is literally get that, and in your one calculator that you're allowed to use, not your phones, try to put all of that exactly the way it looks in here. That means, yes, using the fraction button. That means using the second square root button. That means putting all the negatives and positives, everything that you see there, parentheses and all. Put it exactly the way it is on this specific calculator. Who needs a calculator just to test this one out? Well, come up and get it. 24. If you get any expression and you put it into the calculator and you get a syntax error, that means you either forgot to close a parentheses, you accidentally put in the wrong operation symbol. Instead of a plus, you put a minus sign, and maybe you got negative 15 on this one. Oh, the one on the paper? So, the way you could get syntax error is by a lot of things, you just making a small mistake, right? One of the other main important ones is keeping in mind that on the calculator, the minus sign is a lot different from the negative sign. The negative sign is right next to the decimal down below. Make sure you... Sorry, make sure you use the negative for negative numbers and the minus for operations. If this one was a minus, you would put a minus instead of a negative. That's going to give you syntax error all the time. Okay, let's do one from the worksheet. I'll give you a freebie, but to show you how it might come out of a challenge.
Hey, Neil.
Yeah.
So if you have power,
Minus, negative, oopsies. There you go. Here's a nice looking expression, and it wants you to substitute x, y, and z with -5, -7, and 4. So get those numbers and put it into its proper place. So take a good 2 minutes to 2 or 3 minutes to try to do it.
what's the comment?
Commas are nothing. It's just saying if x equals -5, y equals -7, z equals 4. It's just separating the two.
Oh,
The 3, I should say. Take 2 or 3 minutes to try to do it, and then I'm going to show you what you need to do. Doug, I think I heard you just say it. Is this first one a negative or a minus? So a minus sign is an operation, so it should majority of the times be between two numbers. If there is no number in front of the minus sign, guess what it is? Negative. So negative parentheses x plus y. Again, if it helps, put parentheses on everything. It's just a good habit to have. So let's do this. I'm going to take the long route of putting parentheses around every single variable I see. Because again, if you're beginning with this, it's a good habit to start doing, as tedious as it may sound. So we do negative parentheses. My x, I should be doing this in a new color. Negative parentheses. There is my x. I'm going to substitute my x with parentheses. Plus y. I'm going to substitute my y with parentheses. Then I put this parentheses there, right here. Man, that scared me. Plus 3 parentheses 2. You guys did know that was a 2, right? Okay. Hey, I'm looking back at it and it kind of looks like it would be a Z, but the next one is a Z, obviously. Sorry. There's a Z right there, so I put parentheses around it. Minus y, put parentheses. That's a good, yeah.
The y should also be fine.
Oh my god, sorry. Sorry, yep. The y is a variable, so I gotta put parentheses. Thank you for that. So all I did here, it's a good habit to have, is to rewrite the whole expression, but in place of all the variables, putting parentheses around its spot. Because now, I'm just going to get the values of x, y, z and put it into its designated spot. What should go in here? -5. What should go in here? -7. What should go in here? 4, because it's a z and z is 4. What should go in here? -7. Maybe that's what got y'all. When you were doing your calculations, you probably thought that the -7 substitutes this little subtraction sign. No, this is minus a -7. That is extremely important right there. Hence why we put parentheses first, so that you can visibly see everything. And guess what we do? We now punch this into the calculator, and we get 57, which I'm about to do. I'm about to do it on the calculator for y'all. First things first, I need a calculator.